Everyone. Today I'm here to teach you about the transaction processing concepts and concurrency control techniques. The topics related to this chapter are transaction, properties of it, transaction processing system, concurrent transaction and system concepts, transaction states, schedule, serializability of schedules, concurrency control technique, binary lock operations, two-phase locking, timestamp ordering, optimistic concurrency control technique. From this chapter, totally 14 marks question will be asked according to Bangalore University blueprint. 2 marks 2 questions, 10 marks 1 question. 10 marks question based on only theoretical part. There is no practical part question in this. Moving to the next section, transaction. We need to define what do you mean by transaction. Transaction is a logical unit of execution in an information system. It is a sequence of operations that must be executed as a whole, taking a consistent database state into another consistent database state. The meaning of this is the transaction is a logical unit of execution. When it is executing, it will take the consistent state of present state into the new state. So the logical unit of execution cannot be seen. Internally, it will be performing the transaction between one database to another database. So this process is called transaction. It is also defined as transaction is a unit of program execution that accesses and possibly modifies various data objects. The example of this is transferring from funds from a checking account to a saving account. There are four properties of transaction. These will be called asset properties of a transaction. The asset stands for atomicity, consistency, isolation, durability. Atomicity, a transaction is an atomic unit of processing and it either has to be performed entirely or not at all. Consistency, a successful execution of a transaction must take a consistent database state to a new consistent state. Isolation, a transaction must not make its modifications visible to other transaction until it is committed. Durability, once a transaction has committed its changes, these changes must never get lost due to subsequent system failures. Atomicity is nothing but what? Whatever the possibility processing is there that has to be automatically performed or not performed. It is depends on the database. Consistency, the successful execution of a transaction must be taken place to the new state of database. Isolation is nothing but modifications cannot be visible during the transaction until unless it is committed. Committed is nothing but the transaction that is nothing but a transaction has committed its changes that should not lost because of system failure, because we can't say the change whatever made to the database will remain constant. Why? Because sometimes due to the failure of the system the data may lost from the database. Once you commit what you need to the that should be remain even though if the system affected by any failures. It may be a system failure, it may be a data failure, or it may relate to any hardware failures that it should not affect to the database. Transaction processing system, that will be called as an TPS, are systems with large database and hundreds of concurrent users that are executing database transaction. So for example, in the last video lecture, in the PLSQ, you studied about a client server architecture. In the server side architecture or client server architecture, the server will be connected with the n number of clients. So the same database will exist by n number of users, or the n number of users perform the same operations or different operations on a same database. That is called as a server architecture. Transaction processing system is a large database and hundreds of concurrent users are going to be execute the same database. The transaction processing is supported that are called transaction processing system. For these transactions between the hundreds together, concurrent users connected with the same database execution will be called an transaction processing system. It provides three functions: system runtime function, application development function. The system runtime function ensures integrity, availability, security of the data, fast response time, and high transaction throughput for the data shared among the clients. System administration function provide administrative support that lets user configure, monitor, and manage the transaction systems between server and the client. Application development function. It provides functions for use in customized applications, including functions to access data, to perform inter-computer communications, and to design and manage the user interface. For example, like your bank account. So in the bank, there is a single software that can be accessed with the help of TPS. Why? Because there is a database called as a bank database that will be accessed by several people for specific purposes, and those data will be accessed from the same database. So, for example, one person wanted to access the data for the data transmission, one person wanted to access the data for checking the account details, one person wanted to debit, one person wanted to credit the data from the same database. So, these multiple people wanted to access the data from the same database. At that time, it has to provide us a application function to perform all such kind of an operations with the same database called as in server to the client. Why? Because from the present database we are accessing the consistency towards the new consistency database called as an user defined database. Next, the same thing where I told you now how that server will work. So multi-user system example for this here, client machines will be there. These are two clients. Server, that is nothing but this is a server. Through that server we are going to access data which are needed. The two parties wanted to access some application will be stored in data or database called as data store. So how it will be communicated? There is a communicator between application server and the data store called as an DBS. So presentation server when the request application server, and the application server will send request to DBMS to get the data from the store. So for that we require a communication. This communication will happen to TPS, that is nothing but transfer processing system. So through this communication, the data we want require from the data that will be accessed through application server by the clients. So here this multiple user system example will give client server architecture. Such kind of an architecture is also called an three-layer architecture that you already studied in the beginning of the DBMS. Concurrent transaction. The concept of multi-programming, which allows the computer to execute multiple programs process at the same time. If only a single CPU exists, it can actually execute or at most one process at a time. That is nothing but the concurrency transaction has to provide multi-accessibility. If the CPU is single, it can actually execute the most one processing at a time. If it's connected in a client server architecture, multi-programming operating system execute some commands on one process, other will be suspended. Single user is one user at a time can use the system. There are two types of processing: interlude processing, parallel processing. Concurrency of a process is interlude in a single CPU. It is nothing but if it's a single operating system like a DOS operating system, there the multiple users cannot access the same data at a time. It is called as interlude processing. In multi-user operating system like Windows operating system, Linux or operating system. The same can be stored by number of users. That's called as multi-user. Their processing will happen because processes are concurrent and executed in multiple CPUs. Transaction system concept. Transaction options. Begin transaction, read write transaction, end transaction. Begin transaction, beginning of the transaction, read write two simple operations performed on a data. End transaction is the end of the read write and read, and the end of the execution. These operations will indicate the transaction process, how the system is to be accept those for the system commit point transaction. The system will take care of rollback of transaction and redoing transaction, because sometimes unfortunately we will something can be callback the operation as a rollback, and if you want to repeat the same task, that is nothing but whichever you executed previously that you wanted to call back, that is called as redoing. So similarly, how we perform undo and redo in the other work in the same manner, here we can call or delete the data with the two transaction commit points called rollback transaction undo, redoing transaction as read. Transaction states be defined as state active, partially committed. The final statement has been executed, it is going to be commit. After the discovery, that normal execution can do longer state. About it, the transaction has told the bank and is restored to its state of the start of the transaction. Completed after successful commission. So is it here the option called as delete option, partially completed state, that is, but it is not completely saved. Permanent store be happened with the option called as committed state. That it will new here, that is completed. It indicates the entire process has been done. And if after partially committed state, if it is not able to get a permanent store for completing its transaction, then obviously it will reach to paste is called as failure. Even to perform a read write operation, uh, if it is not able to perform, then it is also reached to the state called as an failed state. We can abort the state execution, that is nothing terminate execution of that active state we want to transact, can be aborted. It is nothing but it can be stored, it can be rolled back, be performed to operation undo or redo, and finally we can reach terminated state which is not able to perform the task completion and transaction. These are the states, and this is the state transition diagram, how the the entire transaction will perform read write operation and operation, and finally perform a terminate operation, which is to be the transaction process has been completed. Schedules. Induction in an interleaved action, the order of execution of operation from the way transaction forms what it is known as transaction. Schedules will be more than one system with the server, then due time will be shared. But if it is in the interleaved fashion, then it's difficulty for the user time out for the execution of the action. Schedules like this: serial issue, non-serial issue. Again, non-serial is defined serializable. Again, in the serializable schedule, view serializable schedule. in the non-serial recoverable schedule, non-recoverable, and in the recoverable cascading schedule, restrict schedule defined. For our study, we will study serial, non-serial, serializable schedule, conflict time, view serializable studies. How schedule will happen? There are two transactions. Read A, write A, read B. So options B, the transaction B in the section. There is an operation called as an serial. Unless it won't finish the transaction, it will not in transaction. Completion of this task that T2 will get the transaction from T1, read A, but B activity is not from transaction 1. Transaction 2 can operates called read activity, write B activity, and become of the entire activity. The serializability of scheduling of this transaction data consist. This serial execution transfers data consistency. We ignore all and options. Is while operating system level